Good morning. Today we are going to be looking at lesson 5.4, and we are going to be trying to figure out what the difference between a factor and a multiple is. So go ahead and find your math journal. We will be on page number 300 today, and you also need your pencil and maybe a multiplication chart if you need it. All right, so again, we are starting on page 300. So remember from last week, we started talking about factors. So factors are the numbers that are being multiplied together. So for example, just a review, if I'm looking for factors of 12, for example, I'm looking for the numbers that when we multiply them, they will equal 12. So I know that 1 and 12 are factors because 1 times 12 will make 12. I know that 2 and 6 are factors because 2 times 6 is 12. And lastly, I know that 3 and 4 are factors because 3 times 4 is 12. So those are factors. Factors are the numbers that we're multiplying together. Today, we're adding in a new vocabulary word called multiples. The easiest way to think about multiples, it's kind of like the number you get when you multiply. So for example, multiples of 12 would be 12, 24, 36, 48, and I'm going to write, no, you can't really see that, but dot, dot, dot means that it keeps going on and on and on. And the way that I'm finding the multiples of 12, maybe you can see the pattern, but the first one, 12, is 12 times 1, then 12 times 2, 12 times 3, 12 times 4, and you could keep multiplying up and up and up, literally forever. You could do 12 times a million if you wanted. So multiples are the numbers that you get when you multiply. So that's kind of the difference between the two. And so we're going to look at some different examples today. The first one on page 300 is talking about something called a common multiple. So you might see this kind of in real life when someone is trying to find, like in this example, 2 days that people have in common. So it says a common multiple is a multiple of 2 or more numbers. So something that they have in common. Common means the same. So the question says, Tony works every 3 days and Amanda works every 5 days. If Tony works June 3rd and Amanda works June 5th, on what days in June will they work together? So using multiples of 3 for Tony and 5 for Amanda, you can figure out the next day that they're going to work on the same day. So use this little calendar. It says circle the multiples of 3. So for Tony, we're circling the multiples of 3. So multiples are the numbers we get when we're multiplying. So 3 times 1 would give me 3. The next multiple would be 6, 9, 12. You might see that, again, we're just counting by 3's. And if you didn't know 3 times 4, for example, you could just count. So if I start at 3, because that's 3 times 1, and then you go 1, 2, 3, 6 would be the next multiple. And then you count 3 more, 1, 2, 3, 9 would be the next one. And keep going up until we figure out all the multiples of 3 on this calendar. So after 12, if you add 3 more, 1, 2, 3, you get 15. Or if you already know your math facts, you can just count by 3's, go for it. So 15, 18, and then now we're on 7 times 3, 8 times 3 now is 24. Add 3 more, you get 27. The last one on this chart is 30. All right, so those are the multiples of 3. Then it says, draw a box around multiples of 5. So now to figure out the days that Amanda's working, we're going to draw a box around the multiples of 5. These will be pretty easy because you're just counting by 5. So start with 5, 5, 10, 15, 20, 25, 30. And so the question says, what days in June will they work together? So you're looking for the multiples that they have in common, that are the same, so that have the circle and the box around them. There are 2, it looks like the 15th and the 30th. So Tony and Amanda will work together on June 15 and June 30th. All right, so that is how you find a common multiple. I think the next examples are just kind of, now we're going to look at the difference, try to identify the difference between factors and multiples. So if you are feeling pretty good about the difference of these, we're looking at the share and show section of page 300. You guys can pause the video here and walk ahead and then come back in and check if you get your answers right. So number 1 says, multiply to list the next 5 multiples of 4. So remember, to find multiples, we're just multiplying. So the first one they did for you was 4, because 4 times 1. Then you could either multiply, you could add 4, or you could just count by 4s if you know how to do that. So 4, 8, because that's 4 times 2, 12, 16, 20, 24. So this is, you don't have to write this, but 4 times 2, 4 times 3, 4 times 4, and so on. And it could keep going up and up and up. They only want the next 5 though. Another thing, if you're using your multiplication chart, you should see that these numbers are the list of numbers in the 4 column or the 4 row. Those in your multiplication chart are all multiples. Okay, so the next section says, is the number a factor of 6? Right, yes or no? So remember that factors of 6 are numbers that you multiply to get 6. So on number 2, can 3 be multiplied by something to get 6? Yes, because 3 times 2 is 6. Number 3, can 6 be multiplied by something to get 6? Yes, 6 times 1 is 6. Number 4, can 16 times something equal 6? No. And number 5, 18, can 18 times something equal 6? No. So remember, try to keep in mind the difference. These are factors. Factors are numbers that we multiply to get something else. The next section now, reverse that, or switch it, and now we're looking for multiples of 6. So look at number 1, those are the multiples of 6. These are the numbers you get when you multiply. So for example, the first multiple of 6 is 6, then it would go 12, and then 18. So is 3 a multiple of 6? Will 6 times something equal 3? No. Number 7, will 6 times something equal 6? Yes, that's the first multiple of 6, 6 times 1. Number 8, will 6 times something equal 16? No. Nothing times 6 will equal 16. And number 9, for 18, will 6 times something equal 18? Yes. If it's confusing to just kind of think in your head for both of these, you could always off to the side list, for example, down here for these, the multiples of 6, so you remember. You could do 6, 12, 18, 6 times 4 is 24, 6 times 5 is 30, and then you could keep going. But that could give you a reminder of what multiples are. And for the the first section, the factors of 6, you could list, 1 times 6 is 6. And I think the only other factors are 2 and 3, because 2 times 3 is 6. And then you can use your little list to match yes or no for those. All right, go ahead and look at page 301. Again, if you're feeling pretty good about this, go ahead and pause and check back in when you're done. Okay, so this next section says, is the number a multiple of 3? Write yes or no. So if you want to go ahead and just give yourself a little cheat up at the top, list some multiples of 3 as a reminder. 3 times 1 is 3, 3 times 2 is 6, 3 times 4 is 9, 3 times 4 is 12, 3 times 5 is 15, and then it keeps going and going and going. Dot, dot, dot means it keeps going on and on and on. Okay, so number 10, is the number a multiple of 3? Is 4 a multiple of 3? That means, can 3 times something equal 4? Look in your list. No. Okay, what about 8? Can 3 times something equal 8? No. What about 24? Can 3 times something equal 24? I didn't list that high, but yes, because I know that 3 times 8 is 24. And then number 13, can 38 or 3 times something equal 38? No. If you think about it, you could use your divisibility rules actually and see if 38 can be divided by 3. Or you might know that 12 times 3 is 36. The next one, 13 times 3, would give me 39. And so it skips right over 38. So that's no. Okay, number 14 says, list the next 9 multiples of each number. All right, that's kind of a lot, but this is easy. So multiples of 2, essentially you're just counting by 2s. So it starts at 2 for you. And we're listing the next 9. So 4, 6, 8, 10, 12, 14, 16, 18, 20. I think that's 9. That's the next 9. Okay, now do the multiples of 8. So count by 8. Now it starts at 8. 8 times 2 is 16. 8 times 3, 24. 32. 40. 6 times 8, 48. 7 times 8, 56. 8 times 8, 64. I'm running out of room. 72. And the last one would be 80. Okay, then it says find the common multiples. So you want to now figure out which ones that 2 and 8 have in common. I'm gonna try to, I wonder if the highlighter is see-through. It is. Okay, let's highlight them. So I had noticed right away that multiple of 8 is 8, and it's also in the list of 2. I see that they both have 16 in the list. And then looking the rest of both lists, I don't see any more that they have in common. So the only 2 multiples that they have in common are 8 and 16. All right. The next section, 15 and 16, don't let the word algebra freak you out. It just says find the unknown number. Look at what pattern, or look what they're counting by. 12, 24, 36. Next number they're counting by 12 is 48. That's 12 times 1, 12 times 2, 12 times 3, and now that would be 12 times 4. Again, if you're having trouble counting by Like, I kind of forgot to say this, but up here, if you had trouble counting by eighths, use your multiplication chart. It's the whole list of eighths. It just goes down the line. And then for 16, figure out what they're counting by. 25, 50, 75, 100. I believe they are counting by 25s. So this should be 125 if you add 25 more. Okay, tell whether 20 is a factor or a multiple of the number, right? Factor, multiple, or neither. All right, so we're talking about the number 20. So off to the side, as just a little hint to myself, I'm going to write, factors. So the numbers that when you multiply them together, they equal 20. I know that one. Uh-oh, my pen stopped working. 1 times 20 would give me 20. I know that 2 times 10 would give me 20. And 4 times 5 would give me 20. Those are the factors. Now think about multiples of 20. So if you're going to count, oh no, pen, multiples of 20. Count by 20s, you'd go 20, 40, 60, and then it would keep going up. So look at 17, 18, and 19. Is 10 a factor, a multiple, or neither? Look in your list that you just made. 10 is a factor. Number 18, 20. I see it in my multiples list and my factors list. So I'm going to write factor. That's an and sign. And a multiple. And then 30. Think or look in your list. Can 30 times something equal 20? No, so it's not a factor. And if you count by 20s, do you ever hit 30? No, so it is neither a factor or a multiple. All right, go ahead and look at the last section. Again, you can try these on your own. But the first two, 20 and 21, are true and false questions. It says, for number 20, is this true or false? Every whole number is a multiple of 1. So I think the easiest way to answer math true and false questions is to try to prove this either right or wrong. So when it says a whole numbers are just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and when we're talking about multiples, we're talking kind of like counting by ones. So if you count by ones, I'm going to list it up here. 1, 2, 3, 4, 5, 6, blah, blah, blah. Is every whole number, every number a multiple of 1? Will every number appear in that list of multiples? Yes, so that is true. I'm gonna say that when it says explain, that's true because 1 times anything will just be itself. And then 21, is this true or false? Every whole number is a factor of 1. So if you think about factors of 1, what times what will equal 1? Only 1. So the only factor of 1 is 1. So is it true that every number is a factor of 1? No, that's false. And you could say because the only factor of 1 is 1. Because the only way to make the number 1 with multiplying is just 1 times 1. All right, number 22, this is kind of like the one you did at the very beginning with the multiples on the calendar. This is Julio wears a blue shirt every 3 days. Larry wears a blue shirt every 4 days. On April 12th, both Julio and Larry wore a blue shirt. What is the next date that they will both wear a blue shirt? All right, so start with your calendar here. Every 3 days, Julio wears a blue shirt. So you're looking for multiples of 3. So I'm going to circle those. Count by 3. It was 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right, then it says Larry wears a blue shirt every 4 days. So now you're looking for multiples of 4. So I'm going to put a box around the multiples of 4. So count by 4 is 4, 8, 12, 16, 20, 24, 28, and I think that's the last one on the calendar. Okay, then it says, on April the 12th, both Julio and Larry wore a blue shirt. You can see that's true because it has a circle and a box on the 12th. What's the next date they will wear a blue shirt? So what's the next date that they have the same multiple or a common multiple? It's the 24th. So the next day they will wear the blue shirt is April 24th. All right, that is the end of lesson 4 in chapter 5. I think that the most difficult part is keeping track of which one's a factor and which one's a multiple. But once you figure that out, I think you're good. Please let me know if you have any questions, and thank you for watching.